In the boundless expanse of the cosmos, the more we learn, the more we realize how little we know. Among the countless mysteries that still elude us, one question stands out with profound significance. Is life, in any form, common throughout the universe, or is Earth the solitary cradle of existence? For millennia, this question has occupied the minds of scientists, philosophers, and dreamers alike. But today, we stand on the precipice of discovery, on the edge of a new era in space exploration, where the possibility of life beyond Earth is no longer a mere fantasy, but a question within our reach. As we gaze into the night sky, we see only the smallest fraction of the stars that fill our galaxy, more than 100 billion of them, each potentially surrounded by its own collection of planets. Some of these planets, orbiting distant stars, may be strikingly similar to our own world, existing in what we call the habitable zone. This is the region around a star where conditions could allow liquid water to exist on the surface, an essential ingredient for life as we know it. But could life actually exist on these far-off worlds? Could we, perhaps, one day discover that we are not alone? These distant worlds, exoplanets, as we call them, are planets that orbit stars outside our solar system. Over the past few decades, the discovery of exoplanets has exploded, revolutionizing our understanding of the universe. What was once a theoretical possibility has become an observable reality. The search for exoplanets is not just about counting planets in other star systems. It's about understanding how planets form, how they evolve, and, perhaps most importantly, whether any of these worlds could harbor life. The sheer number of exoplanets is staggering. Thousands have already been discovered, and more are being found every day. Some of these planets are gas giants, similar to Jupiter or Saturn, while others are rocky and smaller, with surfaces that could resemble our own Earth. These Earth-like exoplanets are particularly intriguing. They exist in the so-called habitable zone, the region around a star where conditions might allow liquid water to exist. Water, as we know, is essential for life as we understand it. But the existence of water alone is not enough to guarantee the emergence of life. In the search for life beyond Earth, we must look for more than just the presence of water. We need to understand the atmospheres of these planets, what gases are present, what the climate is like, and how stable these conditions are. A world with water could still be inhospitable if its atmosphere is too thin, too thick, or full of harmful gases. These are some of the critical factors that determine whether life could exist on an exoplanet. Yet, even with these challenges, the very possibility of discovering a world with the right conditions for life is tantalizing. Imagine a planet orbiting a distant star with conditions that might support life. Perhaps it's a world not unlike our own, where the atmosphere is thick with oxygen and the oceans stretch across vast continents. The air smells fresh, the sun casts a warm glow, and maybe, just maybe, the first stirrings of life, tiny microorganisms, are beginning to take shape in the waters. Perhaps this planet's oceans teem with strange creatures, vastly different from anything we know, evolving in their own time and space. Or perhaps life on this world has taken an unexpected form, based on biochemistry that doesn't rely on carbon or oxygen, but on entirely different elements, creating an entirely new paradigm for what life can be. The search for life on exoplanets is also a search for the unexpected, a journey into realms where life might defy our conventional understanding of biology. On Earth, life thrives in environments that once seemed impossible. In the deep, dark depths of the ocean near hydrothermal vents, in acidic hot springs, and in frozen, inhospitable deserts. If life can exist in such extreme conditions here, why wouldn't it be possible on an exoplanet, perhaps in a form that doesn't require Earth-like conditions at all? The quest to find life beyond Earth begins with science, carefully crafted missions, and powerful telescopes that enable us to peer into the far reaches of space. One of the greatest tools in this effort has been NASA's Kepler Space Telescope, which has discovered thousands of exoplanets, many of them located in the habitable zone of their stars. And now, with the TESS mission, NASA's Transiting Exoplanet Survey satellite, our understanding of these far-off worlds is growing at an unprecedented rate. But finding an exoplanet in the right place is just the first step. The real challenge comes when we try to understand the conditions on these planets. To detect life, we look for biosignatures, molecules or gases in a planet's atmosphere that suggest biological processes. Oxygen, methane, and carbon dioxide are prime examples. On Earth, these gases are primarily produced by life. So, if we were to detect such gases in the atmosphere of a distant exoplanet, it would be an exciting clue that something, possibly life, is at work. However, detecting biosignatures is no easy task. Exoplanets are incredibly distant, and current technology only allows us to study them from afar. But as we develop more advanced telescopes and observational techniques, we are getting closer to identifying potential signs of life. Instruments like the James Webb Space Telescope, set to launch in the near future, will allow scientists to study exoplanet atmospheres in greater detail than ever before. In time, we might be able to detect not just the presence of water or oxygen, but perhaps even the first faint signatures of life itself. While Earth-like exoplanets in the habitable zone are the most likely candidates for harboring life, other possibilities exist. Red dwarf stars, for example, are some of the most common types of stars in our galaxy. These stars are smaller, cooler, and less luminous than our Sun, yet they can support planets in their habitable zones. However, red dwarfs can also emit intense flares and radiation, which could pose challenges for life on nearby planets. But life, as we've seen on Earth, is incredibly resilient. Could life have evolved to withstand the harsh radiation of a red dwarf? Could we one day find life thriving in such an environment, perhaps in a form we never anticipated? The search for life on exoplanets is one of the most exciting frontiers in science. With each new discovery, we draw closer to answering the question that has puzzled humanity for millennia: are we alone? But this quest is not only about finding life elsewhere. It's about expanding our understanding of life itself. By searching for life beyond Earth, we are forced to confront the very definition of life and to consider the vast possibilities that the universe holds. The implications of discovering life on an exoplanet would be profound, reshaping everything we know about biology, evolution, and the uniqueness of our place in the universe. It would be a discovery of cosmic significance, showing us that life is not just a rare occurrence, but perhaps a more common phenomenon than we ever imagined. And yet, even if we do not find life on an exoplanet, the very act of exploration will have changed us. It will have expanded our perspective, revealing just how small and interconnected we are in this vast, mysterious universe. The search for life beyond Earth is more than a scientific endeavor. It is a journey of discovery, a journey that will not only answer profound questions about the universe, but also deepen our understanding of what it means to be alive. As we continue our exploration of the stars, the possibilities are endless, and the search continues. Perhaps one day, we will look up at a distant star and know, without a doubt, that life exists elsewhere in the universe. Until then, the mystery remains, beckoning us to explore further, to dream bigger, and to seek the answers that lie beyond the stars.